Hi, we are going to be looking at identifying direct variation today. Now, we're going to look at it in two different ways. We're going to look at identifying from a table and from an equation. Well, the first thing we're going to look at is our formulas for direct variation. We have y equals kx, that is the main formula. An alternate way of writing this by solving for k is y divided by x equals k. K is your constant of variation. So what we're going to do is we're going to use this second formula here. We're going to take our y values and we're going to divide them by our x values. If we get the same value every time, then we have direct variation. So I'm going to take my 14 and put it over 2. That reduces to 7. Next, I'm going to take my 21, the y value, put it over its corresponding x value, 3. That also reduces to 7. These are equal. So that means I have to test the last value. If they were not equal, I could stop right there and say not direct variation. However, I must test the last one because those two were equal. So 35 over 5, and that also reduces to 7. So what does that mean? It means we have direct variation. All right, let's test our next ones. So putting y over x. All right, how about you hit pause right now and you try it yourself. Ready? Okay, you should have paused the video and tried this yourself. And let's test this. We put 5 over 2. Now that reduces to 2.5. Okay, then we're going to put 7 over 3, and that reduces to 2.3. Now, 2.5 does not equal 2.3, so this is not direct variation. All right, now let's try looking at equations. When you have equations, I want to put it in either this method or this method. The easiest way is to just solve for y. So I'm going to divide each side by 7, everything, and I get y equals 14 divided by 7 is 2x plus 1. Well, if we look at our equations, that's y equals k times x. There is nothing added to or subtracted from this. So this is not direct variation. I'm going to abbreviate it as DV, not direct variation. Okay, look at this next one. We have y equals x divided by 9. You might say, well, there's no division when it's solved for y. But couldn't I write this in this manner? Y equals 1/9 times x? Yes, because if I were to multiply these out, you have x over the 9. So really, the k is a fraction. Okay? So, yes, this is direct variation. And different times you'll be asked to identify your constant of variation when you found direct variation. So here, k would equal 1/9. And in this problem, k would equal 7. Okay, let's try this last one. I want you to try this one on your own. Hit pause and try this, and then when you unpause it, we'll go through it. You should have paused And this is what we should do. First, we're going to solve this for y, so minus 5x. (3y) equals negative 5x plus 0 is negative 5x. Divide everything by 3. Y equals negative 5/3 x. Well, we have y equals number times x. That matches this formula here. So yes, we have direct variation. And you should have written that your constant k is negative 5/3. All right, and that is identifying direct variation from both a table and from an equation.